let's revisit Gauss law from electrostatics. You already know the formula for Gauss law. Integral E dot ds is equal to charge inside or Q inside by epsilon naught, right. So, keep this formula aside now. Let's take this Gaussian surface, a sphere. Let there be a charge Q1, Q2, Q3, Q4 inside, and let there be 3 charges outside Q4, Q5, Q6, Q7. So, any of these charges can be positive or negative, right. As you already know, if the net charge inside this surface is positive, field lines will go outside. If the net charge inside the sum of these charges or the net charge inside is negative, field lines will come in. Let's look at this formula now. Integral E dot ds is equal to Q in by epsilon naught. What you have to understand is the RHS of the formula Q in by epsilon naught is basically the flux through the surface. If this flux is positive or the charge is positive, flux will go out, lines will go out. If the flux is negative or the charge is negative, basically flux will come, lines will come in. This flux depends on the charges inside, right, Q in by epsilon naught. The number of lines, it does not depend on Q5, Q6, Q7, it only depends on Q1, Q2, Q3, Q4. But the LHS of this formula, integral E dot ds, the electric field on the surface of this Gaussian surface, the electric field value, that electric field is due to all these charges. Remember this, the electric field is due to Q1, Q2, Q3, Q4, also Q5, Q1, Q2, Q3, Q4, also Q5, Q6, Q7, like all the charges which are there, whether inside or whether outside. The electric field is due to all of them, but the flux that you see, that only is due to the charges which are present inside. So, this is a trick and this is something that you have to be very thorough with, and you have to remember this as far as Gauss law is concerned.